Hey everyone, welcome. We are now starting chapter 7. I am working in the skinny packet and I am on page 20. So if you want to take a moment, find your packet, and then we'll get started. All right, so in chapter 7, what we're going to start to look at are finding equivalent algebraic expressions. And then this kind of starts our adventure into our third shape of Algebra 1. So we've done a lot of focusing on lines, linear equations. We've got the curve, so our exponential equations, and now we're going to be getting into a U-shape soon, which is our quadratic equations. So we've got linear, exponential, and quadratic. So in our first section, what we're going to do is start to talk about the different polynomials, all right? So a linear function is an example of a polynomial function. The soon-to-be quadratic shape that you're going to learn about is a polynomial function. And so, and in Algebra 2, you'll learn about many different types of polynomial functions in those shapes. So just going through the top part, a polynomial is an expression made up of several terms and or factors. And so this is very important vocab for the rest of Algebra 1 and then when we get into Algebra 2. Terms are those pieces that are separated by the addition and subtraction signs. So like here I have 4 terms, 1, 2, 3, 4. Okay. Factors are separated by multiplication. So here I have 2 factors. And so this is one factor and this is the other factor. And you are already familiar with that term. For instance, if I wanted you to find the factors of 24, right? Its factors are separated by multiplication. So for instance, 1 times 24. 1 and 24 are factors of 24. 2 and 12. 3 and 8. And then 4 and 6. And just as a heads up, I could also throw in their negative version because negative 1 times negative 24 is 24. The same with negative 2 and negative 12, negative 3 and negative 8, and negative 4 and negative 6. So again, factors you are familiar with. Terms might be a slightly newer word for you. So when we write polynomial expressions, so there's also expressions and equations. Equations have an equal sign at the end. Expressions don't. So notice how there's no equal sign here. It's just because there's nothing to set it equal to. What we're going to be doing is just finding equivalent versions of it. I'm not going to try to figure out what x is. I just want to clean it up, simplify it. So typically when we look at a polynomial expression, it's preferred for them to be written in standard form. Another huge word. And it's in standard form when you write it in numerical order based on its exponents. So you want to go from the highest power to the lowest power. So for instance, this is in standard form. I think of it as a countdown like New Year's Eve. So I look for the highest exponent and then I just make sure the exponent following them are getting smaller and smaller. So this is like the 4th power, right? It's not like it is the 4th power. There is no 3rd power. That's okay. We've got the 2nd power. I'm going to use a pencil here because I'm going to erase. When you don't see an exponent like that, that's a 1st power. And then technically, there is an x with the power. It's a 0 power. And maybe you remember from middle school that anything to a 0 power is always 1. So they don't write 10 times x to the 0 power because this is worth 1 and 10 times 1 is 10. But it is technically a full countdown. All right? Some pieces of standard form. The coefficient is the number in front of a variable. So 2 is a coefficient, 3 is a coefficient. Technically, let me erase this one. When you look at this, there's a 1 in front of it, and that's a coefficient. Now, 10 is not a coefficient. A coefficient is just the number in front of the variable. A number that stands alone is called a constant. Because as I start to pick different numbers for x and put them in there, this term can become a different value based on what I make x become. So if I make x 3, then this term is now minus 3. If I make x 7, then this term is minus 7. But this term is always constantly going to be worth 10. Nothing's ever going to change this term's value. So that's why it's called a constant. All right? The degree is the highest exponent. So 4 is my highest degree. And then you have the leading coefficient. So the leading coefficient is, when it is written standard form, it's the number that starts it all off. So what we're going to do is address these four things with these Roman numerals, 1, 2, 3, and 4. So in this one, what's the number of terms? So I've got 1, 2, 3, 4. The next one to address are the two little Roman numerals. The leading coefficient, again, that's this 2. Sorry, no, I messed that up. I wasn't looking at the right spot. Oh, I hope you have an eraser. So it's not 2. I was supposed to do the degree. So again, the degree is the highest exponent, so that should actually be a 4. The third Roman numeral is my leading coefficient, which is the 2. And then the constant is the number at the end, just the plain number with nothing attached to it. All right? So this one was written standard form. The next one's not. So that's what we're going to do first, is just rearrange it into standard form. So what I need to realize is that this minus x to the 5th would actually become like a negative x to the 5th. So I've taken care of that. Following, I should have the positive 3x squared, then plus 2x minus 1. So I've got my countdown. It goes 5, then 2, then 1 to no x or exponent. So let's go through these again. Roman numeral 1, the number of terms, 1, 2, 3, 4. Roman numeral 2, the degree, this is a 5th degree. Okay. The third one is the leading coefficient, and again, there's always a coefficient in front of a variable. So if you don't see one, you imagine that there's a 1 there. So it's -1, that's how we should view it. And then the last one is the constant, so the number at the end, that is technically worth -1. So the standard form really truly is all addition, okay, but it can be a mixture of addition and subtraction. So when you see subtraction, you actually need to view this as, I like to do that saying of add, the opposite. You really need to, again, view that as a -1, okay? All right, next one. I'm going to put this in standard form, so I notice I have a -3x to the 4th. So I'm going to put that in front as a -3x to the 4th. Then I got a third power. Oh, look, there's another third power, which I did not notice. Let's fix that. So when I combine this one with this one, wasn't looking carefully, that actually becomes 5x to the 3rd. So I'm going to fix that real quick. They were tricking us, weren't they? And then I go for the x, because that's the next thing that's happening. So -2x. And then I notice I have a 7 and a 4, which I can turn into 11. So I had to do a little simplifying, a little cleaning up. All right, our Roman numerals. Our number of terms is 1, 2, 3, 4. That seems to be a constant thing so far. The next thing is the leading coefficient. That's the -3. Next, we're going to answer, oh, shoot, I did it again. I'm looking at the wrong spot. The leading coefficient is the third option. The degree is the second option, which is a 4th degree. And the last thing is the constant at the end, which is 11. All right, last one. So here, again, standard form is made up of terms. So what I should not see in there are parentheses, because parentheses mean that there's some multiplication happening that can be simplified. So I actually need to distribute this through first. Okay? So -2x squared minus 2. Then I have the 7 with this. And so noticing real quick, when I do start to simplify it, that I can combine these like terms and I can combine these like terms. So I'm going to keep that in mind as I do that. So standard form, I'll start with my highest power, 5x to the 3rd power. When I put these two together, I can view this as like a -2x squared, and a -3x squared becomes a negative or -5x squared. And then when I put my two just numbers together, look at it as a -2 and a 7, that's like a +5. So my constant becomes 5. So going through those Roman numerals, I won't mess this one up. So we put it in standard form, but the first thing we have to address is the number of terms, which this time is 3. 1, 2, 3. Then we're going to address the degree, which is a 3rd degree. And then the next thing we're going to do is the leading coefficient, which is a 5. And the final thing we're going to address is the constant at the end, which is also a 5. All right, that's that. So in addition to understanding the parts of a polynomial, you also have to be able to classify it. So basically what we're going to do is we're going to name it. And we're going to give it a first name and a last name. Every now and then there's like a one-namer, like, I don't know, my age knows Madonna and Cher. I'm sure you guys have The Weekend, right? That's a one-namer. So anyway, we are going to classify it based on its degree. So let's add to that its highest degree and the number of terms. All right? So I like to start with the number of terms. If there's one term, it's going to be known as a monomial. If you see two terms, then it's a binomial. Sorry. Three terms would be a trinomial. Oh, should not have spaced that out. And if it's 4 or higher, so greater, we're going to add this to it, 4 or more, so greater than or equal to 4, it's just going to get a generic name of polynomial. And so that should be very similar. If you think about it in geometry, like a many-sided figure is a polygon, but certain polygons based on the number of sides get a specific name. So you can have a triangle, you can have a quadrilateral, which is 4 sides, a pentagon, 5 sides, and eventually, when there are just too many sides to count, you just call it a polygon. All right, based on its highest degree. So again, even though it's not there, if you see a 1, that's like the first degree. So this is called linear. A second degree as your highest degree is a quadratic. A third degree is going to be called a cubic. And then a fourth degree actually has a name. It's called quartic. All right? So just a few notes. I don't know why these were not added there. If there is absolutely no degree, so if you just see, for instance, no degree, all right, so again, no degree was like that example that I showed you up here. Remember when I said the countdown goes 4 and then it works its way down, and technically there is a 0 there, like that. So if you don't see any x at all, and it's one term, there's a special few names for some of them. So if there is just, again, hold on a second. All right, I had to pause to think about how I wanted to say this. So if you just see a number, so that means one term, ooh, this is B and M, no variable, then that has a special name. It's called a constant. Okay, so just something to keep in mind. All right, let's move on to the next page. So what we're going to do is, all on its own, is we are going to now classify these. So we will write it in standard form if it's not, and then we're going to give it, classify it. So think of it as giving it a first name and a last name. All right, and just going back here, this tends to be the first name, the degree, and the number of terms is the last name. It really doesn't matter, but you usually would hear these words first and then that. All right, so let's put this one in standard form. So I want the x squared first, then the minus 3x, and then the 10. So based on this, right, we're going to give it its name. So its degree, again, that's the highest exponent, is a 2, and the number of terms is 3. And if I know that, I can come here, and if it's a degree of 2, it's a quadratic, and 3 terms is a trinomial. So quadratic, trinomial. This is a very popular one in Algebra 1 and Algebra 2, a quadratic trinomial. All right, so for this one, it's in standard form. Don't really have to rewrite it. I'll just make it bigger. So when I go for its degree, even though I don't see it, there's a first degree there. And then the number of terms is also 1. So when I go here, this non-visible 1 is a linear, and one term is monomial. A linear monomial. Next one. So I start with my highest degree first, so x to the 5th, and then I notice I have a plus 2x squared, and then I'll put the plus 3x, and then I'll finish it with the minus 5. So again, the degree, this is a 5th degree. I mean, this time I wrote 5th, I could just write a 5. And the number of terms is 4. So if I give this a name, we should probably add that here. So pause, time out on that problem. Let's come back. So once you start to have greater than or equal to 5, then it's just the nth degree. Oh, shoot, I should have written this better. And so basically, if it's a 5, it's a 5th degree. It's a 6, it's a 6th degree. It's a 7, it's a 7th degree. So for this one, I would call this a 5th degree, because there's no more special name for it. And then 4, remember 4 or more is a polynomial. And then the last one. So this is in standard form. When I look at its degree, it's a 2nd degree. The number of terms is 2. And so when I go back to this, a 2nd degree is a quadratic and 2 terms is a binomial. So I would call this a quadratic binomial. Real quick, the shapes that you should know already for all of these is linear. This is a line. This is our mx. Technically, if I had to add a b, I'd add plus 0 because adding 0 doesn't change it. I should be aware that this shape is a line. All right? When you see x squared, its overall general name is a quadratic. Just for a heads up, that is going to be looking like a U. Now this U might flip upside down, but in these particular ones, it wouldn't be flipping upside down. That's a later chapter. So 1st degree, you guys know this. You've been working with linear equations since middle school. Quadratics are always a U shape. And then eventually what you'll learn in Algebra 2 is that if your exponent is an odd exponent, just like this one, right? If the highest exponent is an odd exponent, what it's going to do is in the end, it's going to look like the line. It's going to have these same behaviors on the sides. Like here it's going down on the left and it's going up on the right. That's what would happen here. Except what we would start to see are some like bumps in our line along the way. So it's still like a line. Imagine if this were string, I could just straighten it out and it would become string that goes uphill. And just remember, lines can go downhill. And then U's would just be like an upside down U, so maybe look like lowercase n. All right, those are our notes for 7.1.